Now it's just looking at tests for parallelograms. So we're still working with parallelograms and their properties. So we want to figure out when a quadrilateral is a parallelogram. So there are 5 ways that we can prove our quadrilateral is a parallelogram. Okay, so the first way to prove a quadrilateral parallelogram is if both pairs of opposite sides are parallel. Okay, then the figure would be a parallelogram. So if I have side AB parallel to DC, meaning they have these arrows in them, right? And I have AD parallel to BC. Okay, so if both sets of sides are parallel to each other, that is a parallelogram. So, second one, if both pairs of opposite sides are congruent. Okay, or they're equal to each other. So in this case, if I had AB congruent to DC, so if I had that dash mark in there, and I had AD, so this side, congruent to this side. Okay, so AD congruent to BC. So both sets of your opposite sides have to be congruent. Then you could say it was a parallelogram. The third way, if both pairs of opposite angles are congruent. Okay, so with our opposite angles, we have ABC, so that's this angle here, is congruent to ADC. Oops. That's just one dash. Okay, so if this angle is congruent to this angle, and angle BAD, so this one right here, is congruent to BCD, this one right here. Okay, so if both pairs of our opposite angles are congruent, then it is a parallelogram. The next one, if the diagonals bisect each other, then it's a parallelogram. So if I know AE is congruent to EC, okay, so those two pieces are congruent, and I know ED is congruent to EB, then this has to be a parallelogram. So you're just looking at the diagonals for that part. So if E is kind of like that midpoint of both of your segments drawn into that parallelogram, then it's a parallelogram. The last one, if one pair of opposite sides is congruent and parallel. So if you have AB parallel to DC, and you know AB is congruent to DC. So that's all you're given is those arrows and one congruency marker within that same side. That would make a parallelogram. Okay, does that make sense? Okay, so one pair, parallel, and congruent. If you had one pair parallel and the other pieces were congruent, that doesn't technically make a parallelogram. You can't prove that it's a parallelogram. Okay? They have to be on that same segment, parallel and congruent. Any questions on our different reasons here? Okay, so next what we're going to do is kind of what we did the past 2 days, except now we're thinking about it as we want to make this a parallelogram. Yeah.
So we do the same thing, but we just gotta
We'll go through it. So we want to find x and y so that FGHJ is a parallelogram. So since we're given the sides, in order for that to be a parallelogram, those opposite sides need to be congruent. So we want to find x and y to make those sides congruent to each other. Well, I have this 6x plus 3, and 15 is its opposite side. Okay, for that to be a parallelogram, those sides need to be congruent. So I can set 6x plus 3 equal to 15, because I want them to be equal in length. Subtract 3. I get 6x is equal to 12. Divide by 6. X is 2. Yes. Okay. Then I also need my other sides, or opposite sides, congruent. So I need FJ congruent to GH. So since I found x, I can plug in 2 for x there. So I have 4 times 2 minus 2y. And that has to equal its opposite side. Stop talking, please. So we'll multiply 4 and 2. We'll subtract 8. And divide by negative 2. So to make this a parallelogram, x would have to be 2 and y would have to be 3. That way those opposite sides are congruent. Not all. Almost done. Yeah, do number 1 by yourself. Okay, number 1. It's similar to the one we just did. Do that one by yourself. You like this section?
It's actually really good for you. Yeah, for now. 6 years. As long as we're not doing like number 2 thesis statement. I ain't doing that.
Relax. All right, so number 1. Be quiet now, please. So for this to be a parallelogram, we have to make sure our opposite sides are congruent. So I can set 2x minus 2 equal to 12. So I have 2x is equal to 14. So x is 7. My other opposite sides here have to be equal. So we have 2y equals 8. So y will equal 4. Okay, so I have x is 7, y is 4. If I were to plug those in, your opposite sides would be congruent, and yes, that would make a parallelogram. For number 2, for your parallelogram, you need both pairs of opposite angles to be congruent to each other. Okay, so for this one here, I have opposite angles that need to be congruent for it to be a parallelogram. So to be congruent, that means they have to have equal measures. So I can set 11x equal to 55. Divide by 11. And x is 5. Now, if this is a parallelogram, I also know my consecutive angles, so the ones next to each other have to add together to be 180. So I can say 5y plus 55 is equal to 180. If I subtract 55, 5y will be equal to 125. Divide by 5. And y is 25. Okay, so that's the one piece that most people forget. So if you have two angles next to each other, they add to 180. Any questions on those two problems? No. All right. So now what we want to do on the back is determine whether each quadrilateral, so a four-sided figure, is a parallelogram. Okay? And we want to use the statements that we went over in that chart on the front. So in number 7, I have one pair of opposite sides parallel and congruent to each other. So if I look at the front, do I have a statement where it says opposite sides are parallel and congruent? Number 5. So yes, this would make a parallelogram because I found a statement. Okay? And that statement is one pair of opposite sides is parallel and go to the bathroom. Okay, so yes, one pair of opposite sides is parallel and congruent. That's one of your statements. Okay, now I want to look at number 8. Looking at that picture, I have opposite sides congruent here and opposite sides congruent here. So that means both pairs of opposite angles are congruent. Do I have a statement that says that? Number 3. Okay, so since one of those statements says that, this would be, yes, it is a parallelogram. And that statement is, if both pairs of opposite angles are congruent, then the figure is a parallelogram. Okay, so that's what you want to look for. You want to look for these markers within your figure and see if that is one of the statements from that table in the front. Okay, does that make sense? Awesome. So we're going to do the same thing with these bottom ones, except we're just going to write yes or no. And we're going to use that same figure for all 5. So I'm going to help you with this first one here. Yes, you can go to the bathroom.
I'll do that, guys.
So number 10, we're given OR is congruent to CK. So I have one pair of opposite sides congruent, right? And I have OC is congruent to RK. So these two sides. Okay, so now I have both pairs of opposite sides congruent. So yes, this does make a parallelogram. Okay, do you kind of see what I'm doing there? Okay, I want you guys to try 11 to 14. Okay, look at what you're given and then state if it's a parallelogram with yes or no.
Oh yeah, never mind.
Is it yes for every single one of them? I won't break your pen. What is paper thick? Are they all yes? I thought they were all no.
They're all yes. Jayla.
Yes, they're all no. The first two. No, I got yes, yes, no, and I don't know the last one. Hi, you were wrong. Are they all right? I mean,
Yeah.
I watched where the first time I said that.
Okay, so in number 10, what we had was both sides congruent, right? So I'm just going to write both congruent. If I look at, we're quiet now, please. If I look at number 11, I have RK congruent to OC, so my opposite sides are congruent there. And RK is parallel to OC. Okay, so it's congruent and parallel. Okay, so this would be yes. And that one is that last statement on the front. It's number 5. Okay, so if one is parallel and congruent. Okay, so one pair of opposite sides is parallel and congruent. Number 12, I have OR is parallel to CK, so I have opposite sides parallel. And OC parallel to RK, so another pair of opposite sides parallel. Okay, so both pairs are parallel. So yes, this is a parallelogram. 13, RS is equal to SC. So I know my diagonal has that midpoint there. And KS is equal to SO. So again, my diagonal has that midpoint. So this one, you have bisecting diagonals. And if you look at the front, where it says the diagonals bisect each other, that's number 4. Okay? So this one is also yes. Okay, and then the last one, I have angle ROC, so this angle here is congruent to angle CKR, so the angle across, so I have opposite angles congruent. And then I also have KRO, this one, congruent to OCK, this one. Again, opposite angles are congruent. So this one, I have both pairs of opposite angles congruent. So if I have both opposite angles congruent, this is also yes. Okay, so all 5 of those were examples of each one on the front. Okay? Any questions?